Sums of logarithms. So we're going to start off by adding logs to. Now, what is a logarithm? What's a log? A logarithm is an dead air. What's a log? Starts with an E and ends with an onent. An exponent. So a logarithm is an exponent. Okay, so what log? So the logarithm is the exponent that I raised. These are all base 2 logs. So 2 to the power of what gives me 2? Yeah, it is that easy. Yeah, I know. It can't be that. Yeah, 1. 2 to the what gives me 4? 2. 2 to the what? I think you can fill in the rest, right? Yes.
Isn't there a question of adding logarithms on the machine?
Different kind. Not like this. Okay, so we all filled in?
Yep.
Okay, we want to use the above values to help you complete the following. Okay? And yeah, there was a question on the test, like, but not really like that. Because they weren't the same base. Okay. So we're going to go across, right? So the first one is done for you. The log base 2 of 4 plus the log base 2 of 8. Okay, we look up here. Log base 2 of 4 is 2. Log base 2 of 8 is 3, which is 5. And what's that equal to? We look in the table, we say 5. That's the log base 2 of 32. Whoops. Scroll the wrong way. Okay? Do the next one together, you can do the rest. So log base 2 of 2 plus log base 2 of 32. Log base 2 of 2 is? Log base 2 of 32 is? 1 plus 5 is? And the log base 2 or 6 is equal to what? Log base 2 of 64. Okay, take a moment, fill in the rest. I will pause because we don't need that. So that's an 8. The sum is 10, so that must be 7. And the log base 2 of 128 is 7. And 10 gives us 1024. Log base 2 of 1024, working backwards, is 10. The log base 2 of 4 is 2. I'm going to add something to 2 to make 10, which is 8. And the log base 2 of 8 is, what is the log base 2 of 8? 256. Okay, so, got everything filled in? Looks like that? Or I messed up and you'll tell me and I'll fix it? No? Okay, good. Looks like that? Take one of each. They're behind me. For each of the above statements, compare the first expression to the last expression and use your results to predict the following, right? So the first expression we want to look at, like, log base 2 of 4 plus log base 2 of 8 is log base 2 of 32. Or log base 2 of 2 plus log base 2 of 32 is log base 2 of 64. Or, and so on, right? So if we compare them, then what's your prediction for log base 2 of 2 plus log base 2 of 8? Log base 2 of 16. How about log base 2 of 16 and log base 2 of 4? 64. Russell, get out a calculator instead of a cell phone. It'll work better. Log base 2 of 8 plus log base 2 of 8. Say it out loud. 64. Log base 2 of 2 plus log base 2 of 64. 128. From your investigation, complete the following. Law of logarithms. If I have the log base a of m plus the log base a of n, that's equal to the log base a of mn, right? M times n, right? The product. mn. Or we can say that log base a of m, or the log base a of what, is equal to this. mn, right? So we can state that in two different ways, right? And that's what we're going to do. The sum of the logs of two numbers, right? That's what we first investigated. We found the logs of two different numbers. We added them together is equal to the log of the, what goes in here? So the sum of the logs of two numbers is equal to the log of the, what do you call that? It's like elementary school. Multiply two numbers together, the result is called the product. Is equal to the log of the product of the two numbers. Or the log of the product of two numbers is equal to the sum of the logs of the two numbers. Okay? So if we're adding together two separate logs, right? Log base, and they have to be the same base, right? You can't have different bases. So you have log base A of one number and log base A of another number. That's the same as the log of the product of the two, right? Use your rule to express log base 264 as the sum of two logs in as many ways as possible. One has been completed for you. So we can write the log base 2 of 64 as log base 2, 1 plus log base 2, 64. What's the next one that we would probably write? So log base 2 of, really? Come on, logically 2. Plus log base 2 of, okay? And then you should be able to write a few more, right? You may want to be systematic about it. So what's the important thing about these two numbers that I'm going to write it as? So what's important about this number and this number? Like go get a coffee or something and come back. What's important about those two numbers? Their product is 64. So what's another two numbers? 4 and 16. What's another two numbers? That it? That's it for twos. I mean, you could write it as any two numbers that multiply to 64. Right? So, you know, try to think of two numbers. So we got 1 and 64. You know, like what if they don't go in evenly? You know, you could write it as like 64 thirds and 3. Okay. See, and because you can do each of these, right? You know the log base 2 of 2, and you know the log base 2 of 32. You know the log base 2. You know the log base 2 of any power of 2, right? You just got to sit there and count it on your fingers or punch it in your calculator. You can get these, right? You don't need a calculator to do log base 2 of 8, right? I say 2 to the what is 8, and you say 3. 2 to the what is 3. I don't know, like it's bigger than 1 but smaller than 2, right? Because 2 to the 1 is 2 and 2 squared is 4, so 3 is somewhere between. But I don't know what that is. But I do know that I can rewrite this as this and then come up with the answer, right? So I don't know these individual logs, but when I put them together using the law of logs, it becomes a log that I can do, right? I can do 2 to the what is 64. Okay? All right, let's go up and over, which really in this case is up and over. Differences of logs. Okay, so you got the same, you're going to use the same values on the left-hand side of the page, right? log base, we'll do the first one. Log base 2 of 64 minus log base 2 of 4. So log base 2 of 64 is 6. Log base 2 of 4 is 2. 6 minus 2 is, and 4 is equal to log base 2 of 16. Okay? I'm going to pause. You're going to do. Okay, so we're just working through these, and I'm just filling these in as we go along, and then you can check and make sure I didn't mess anything up, or I did mess stuff up. 10 minus something is 6, and that's 4, and the log base 2 of 6 is 64. Log base 2 of 64 is 6, and that's a 1, and so that must be a 7. 128. Okay, how's it look? Good? I should mess one up on purpose just to see if it'll say. But most mistakes I make aren't on purpose. So. For each of the above statements, compare the first expression to the last expression. So again, now we want to look at it won't be long. Okay. Yep. Get out here. Yep. Okay, send them down in 10 minutes. Okay. So Julie and Brianna to guidance after we're done this, okay? Yeah. So we want to look at log base 2 of 64 minus log base 2 of 4 and say, how do we get the 16? What do we do with 32 and 8 to get the 4? What do we do with 8 and 4 to get 2, 32? What do we do? Well, what's your prediction? What's log base 2 of 32 minus log base 2 of 2? 16. What's 256? Log base 2 of 256 minus log base 2 of 4? 64. What's log base 2 of 128 minus log base 2 of 16? What's log base 2 of 512 minus log base 2 of 32? How are you doing all those? What operation? Oh, you were just looking up there. So what was the operation you do? How do we do? What do we do with 32 and 2 to get 16? Divide, right? So log base a of m minus log base a of n is equal to log base a of. Message. What? What? Okay. Log base a of m minus log base a of n is the log base a of m over n, right? M divided by m. Not a great m. Whoa, moved everything. Hang on. All I wanted to do was erase. Oh, now I get the eraser. Okay. So m over n, or the log base a of what is equal to log base a of m minus log base a of. Also m over n. Need one of each. The difference of the logs of two numbers is equal to the log of the, fancy word for division, the result of a division is called a quotient. Of the two numbers, or the log of the quotient of two numbers is equal to the difference of the logs of the two numbers, right? What's a logarithm? It's an exponent. Remember the exponent laws? What do we do when we have powers with the same base and we're multiplying? What do we do with the exponents? Add them. So when we add two logs together, we're really adding two exponents together, right? And what do you get then? You get the product. When we take two powers with the same base and we divide, we subtract, right? Getting a difference. So when we have the difference between two logs, and a log is just an, you got to say it because nobody else in the room is going to. And log is just an exponent, then when we take the difference between exponents, you think back to your exponent laws, then the operation I'm doing is dividing, right? Okay, last one. Logs of powers. To determine the log of a power, we can do the following. Log base 3, hey, different log, of 2 to the 5th is the log base 3 of 2 times 2 times 2 times 2 times 2, right? 2 to the 5th is 2 times 2, 5 times. Which is, using the product law, if we have the log of a product, it becomes the sum of the individual logs. Right? It's not restricted to two things when a product, right? If you can write something as a product of 3 different things, then you can split it up as 3 individual logs, right? It's the log of this, plus the log of this, plus the log of this. So we have 1, 2, 3, 4, 5 of these, which is 5 times log base 3 of 2. We want to repeat the process for log base 6 of 4 cubed. Okay, so we're going to write log. The base is 6, and 4 cubed is 4 times 4 times 4. We have the log of a product. We look on our formula sheet, right? Because we don't memorize these things. We just simply, we get familiar with them. We use them. We do a lot of work with them, hopefully, so that when we see them later, we know what we're doing. And, then we get to use them. But, you need some familiarity with this. So when you say, oh, I've got a product, and I look at my log sheet and say, what do I do with product? Oh, right, I add them up, right? And the bases stay the same, but I add them up. And then I've got 3 of them, right? So 1, 2, 3, so it becomes 3 times log base 6 of 4. This is really one of the more useful of the logs, right? The laws, because you don't know it yet, but it's what's going to help us solve a logarithmic, or solve an exponential, right? If we have remember the unknown exponent? Right now, if you want to do 2 to the x equals 20, right? You got to graph 2 to the x, you got to graph the 20. There's a way to do it using these laws of logs, which makes it very simple. Okay? And log base 5 of 7 to the 4th is log base 5. 7 to the 4th is 7 times itself 4 times. It's the log of a product, so we write it as the sum of the individual logs. So log base 5, 7, plus log base 5, 7, plus log base 5, 7. And how many of those do we have? 4 of them, so it's 4 times log base 5, 7. So for each statement above, compare the first expression to the last expression. The log base 6 of 4 cubed is 3 times the log base 6 of 4. The log base 5 of 7 to the 4th is 4 times the log base 5 of 7. So the last law, the log base a of m to the power n is n times log base a of m. Okay, that was written, yeah, written on your formula sheet. The log of a power is equal to the blank times the log of the base of the power. So it's equal to the, what's that? It's called the exponent. So when you're doing the log of a power, so remember a power is a base raised to an exponent. That whole thing is called a power, right? This is a power. M is the base, and little n is the exponent. Okay? Is that it? That is. Okay, so hang on, I'm just going to... What's the base on this log? I'm actually pointing because you can't even see that. You're saying this log. So these are base 10 logs. Using our laws of logs, what is log base 10 of 12 plus log base 10 of 2 equal to? 24, right? The product. And so you might say, well, why is that? Or, can we use exponents? So if we said let x equal log 12 and y equal log 2, then I can now change these to exponential form, right? So we say take the base, which is 10, raise it to the exponent, which is x. Remember, a log is an exponent, so x is the exponent. So 10 to the x is equal to 12. And 10 to the y is equal to 2, right? Again, base 10 to the exponent y is equal to the argument or the value, 2. If we then multiply, right, because we want log-based, we're going to multiply these two things together, right? So we know that 10 to the x is 12 and 10 to the y. So if we take 10 to the x times 10 to the y, using our exponent laws, that's 10 to the power of x plus y, right? 10 to the power of x plus y is 24. Okay, and that is 24. And then we can write this in log terms, right, by taking the log base 10 of 24 is equal to x plus y, right? Changing that back from exponential form into logarithmic form, right? The log, the base of, whatever the base, in this case 10, so we don't need to write it, of 24 is the exponent x plus y. All right, let's just do a few practical questions. Log base 2 of 5 plus log base 2 of 6.4. Log base 2 5 plus log base 2 6.4. We cannot work out either of those, right? What's log base 2 of 5? Somewhere between 2 and 3, right? Because 2 squared is 4 and 2 cubed is 8. And what's log base 2 of 6.4? Somewhere between 2 and 3. But the laws of log say that this is the same as the log base 2 of what? 5 times 6.4. Just use it times. And what's 5 times 6.4? 32. And what's the log base 2 of 32? 5. So we can solve a problem that we couldn't solve before. I don't know log base 2 of 5. I don't even know how to find that. I don't know log base 2 of 6.4 either. I know what it's around, but I do know that the laws of log say if I have the log of a product, then that's the same as, or sorry, if I have the sum of individual logs, it's the same as the log of the product of those numbers, right? So we make it a single log base 232, and this we can work out, which is 5. Okay, let's do log base 5 of 100 minus log base 5 of 4. Okay, we don't know what either of those are, right? I mean, they're numbers, they're exponents. I'm subtracting, so what do I do with these two numbers? Divide, right? So it's the log base 5 of 100 divided by 4. What's 100 divided by 4? 25. 5 to the what gives me 25? 2. Okay, so we get 2. Log base 3. The log base 3 of 27 to the power of 5. We could actually work this out, right? Because we know that 27 is a power, and we could do some other manipulation in that. But the easy way to do this is to say, what's that equal to, based on our laws of logs?
5 log 3.
Yeah, it's 5 times log base 3 of 27. 3 to the what? What is log 327? So you say 3 to the power of what gives me 27, so 3 to the 1 is 3, 3 squared is 9, 3 cubed is 27. So log base 3 of 27 is 3, and 5 times 3 is 15. Okay, here, I'll show you another way. Here's another way you could do this, not as easy. You could go log base 3 of 27 to the 5th, and you could say, wait, 27 is a power of 3, right? So that 27 can be written as 3 cubed, and then that's raised to the power of 5. Just like we did it with exponents, right? When we're solving exponents, we'd have to rewrite them as powers with the same base. In this case, we want to rewrite it with a base of 3, because when the bases match up, so we get log base 3 of 3 to the 15th. So 3 to the power of what gives you 3 to the power of 15? And it is just 15, right? See, when these two guys are the same, when the base of the log and the base of a power are the same, then the answer is just the exponent, right? Okay. All right, let's do a couple more. Log base 3 of 18 plus log base 3 of 3 halves. And the idea is to basically evaluate this, right? Again, without a calculator. Well, we don't know how to do this on a calculator. Okay, I'm adding, so what do I do? Multiply, right? So it'd be 18 times 3 halves. 18 times 3 halves is 27. And the log base 3 of 27 is 3, right? We've done that one 100 times now. Okay. So you're going to get to know some of these pretty well, right? Log base 2 of 16 is 4. Log base 3 of 27 is 3. Right? I mean, just practicing is going to help you. Log base 5, oh, here's one. Log base 5 of 40 minus 3 times log base 5 of 2. Let's just separate that out. So what do we do? What do the laws say when I'm subtracting? When we have the difference of individual logs, we want the log of the quotient, right? We want to divide. But there's a problem here. This isn't an individual log. It's got a 3 in front. So how do we get that 3 out of the front of this? So log base 5, 40, that stays, right? Log base 5. So where does this 3 go? What do I do? Power, right? Make the 3 the exponent. So it works both ways, right? That exponent law works both ways, right? If you have the log and it's a power, so it's got an exponent on it, then you can move that exponent out front and multiply it by the log. If you have a number in front of the log, I'm multiplying it, then that number can be moved back into the log by just taking it and putting it in its place as an exponent. Okay, now what's log base? So we got log base 5 of 40 minus log base 5. 2 to the power of 3 is 8. We've got the log of we've got the difference of 2 logs, so that gets written as the log of a quotient. And 40 divided by 8 is, and the log base 5 of 5 is 1, right? 5 to the 1 gives you 5. Okay, so summarize. So laws of logs, and the key ideas are on 446. You've got that sheet to help you with it. Summarize the laws of logs. You now have the formula sheet that you will be using in 30-2. So that's the one that you're going to get from now on tests. Not that one. So that's your copy. Make whatever notes on it you want. If you want to write stuff on it or whatever, that's great. I have a copy, an orange one, that I will give you for tests that you will please not write on. Okay, because they need to be pristine. When you hit the diploma and you pull that sheet out of the back, feel free to write on it, right? As soon as you're in the diploma, they'll say tear out the sheets at the back, and one of those is the formula sheet. And at that point, if you want to start writing on it stuff, then by all means, right? If you want to add other formulas or just make a note that this is, whatever, then feel free to do that. Okay, but not on our test, so you leave it blank. So anything you want to write on that, feel free to explain stuff to yourself. Use those logs, do the practice questions, okay, very important practice questions. And I think we're done.